Okay, today we're going to be going over a perimeter and geometry application. We're going to have some geometric problems here that we're going to tie in with the previous lesson of solving linear equations. So our goal in this is going to be mainly finding a value for a variable and being able to use that value to check our work and find some additional measurements. Okay, for the first problem here, example 1, perimeter. Determine the value of x and side measurements of the following rectangle. Perimeter is meaning the sum of the edges of the figure, and they're telling us that we have a perimeter of 12 meters. Now, a couple things. When we start this problem here, what we want to identify is the things that we are looking to find. We're trying to find the value of x. We're trying to find its side. We're trying to find the side measurements of this rectangle. Okay. So those are two things that we're going to be looking for in this problem, the value of x and the side measurements. Now, dealing with a rectangle, hopefully we're able to recall back when we talked about in middle school characteristics of a rectangle. What we do know about a rectangle is that opposite sides of a rectangle are congruent, also known as equal. So if we know this left side here has a measurement of x, the right side is also going to have a measurement of x. And just the same with the top and the bottom, they're going to have the same equation of 2x plus 4. Okay? Now that we have an equation for all four sides, we're going to be able to add all four of them together and set them equal to the perimeter that they tell us, which is this 12 here. So we're going to have x. Our next side was 2x plus 4. Our next side was x. Our final side was another 2x plus 4. So once again, we want to add everything together. And we are going to set that equal to what they tell us the perimeter is, the 12 meters. Now, the first thing we want to do is we want to combine like terms on the left side here. We want to combine everything that has an x, and then we'll see what's left over, and we'll combine those like terms of the integers. So we have an x, we have a 2x, we have another x, we have another 2x. Now, be careful here when we say how many x's do we have, because the common notion is that we say we have 4 x's, because students will see 4 x's. Keep in mind, there's a single x right here, there's 2 x's right here, there's a single x here, and there's 2 x's here. If it helps, put a 1 in front of your variable so you know that you have 1x, you have 2x, you have 1x, you have 2x. So if we add those numbers in front of the variables together, 1 plus 2 being 3, plus 1 being 4, plus 2 being 6, we know that we have 6 x's right here. Okay, that's combining those variables. Let's combine everything that's left, which should be just our integers. We have a 4 and a 4. It's a positive 4 and a positive 4. If we add those together, we get 8. Now, we cannot add these two together. We could multiply them, but since we're adding, if we were subtracting, we'd have the same rule. We cannot combine them together because this is a variable and this is a constant. Okay, but they're still equal to 12 here at the end. Now, the nice thing here is this is what we were doing on Friday, trying to solve for a variable. That's how we were able to connect it to the geometry here. So once again, opposite PEMDAS, okay, working backwards of order of operations, we want to get rid of the plus 8 first by subtracting 8. Golden rule of algebra states what we do to one side, we have to do to the other. So the 8's cancel out, leaving us with a 6x is equal to 12 minus 8, which is 4. And finally, get rid of a times 6 by dividing 6 from both sides. 6's on the left are going to cancel out, leaving us with x is equal to, now we don't want to leave it as 4 over 6, okay, because that can simplify. A number that I can divide both 4 and 6 by is 2. In doing so, on the top we're going to get 4 divided by 2, which is 2. On the bottom we're going to get 6 divided by 2, which is 3. A reminder that this is one of the two ways we can leave our final answer. Another way is by putting it in decimal form. Now, as you recall, as we want to have this rounded to the nearest thousandth, okay? So since 2/3 is 0.6 repeating, the fourth 6 would tell the third 6 to go up to a 0.667, okay? Now, even though I'm circling or blocking this off here, this is not our final answer. It's just one of our two answers, because we are also asked to find the side measurements. So we're going to use the fraction here to get a little bit of a practice here with common denominator eventually. Now, we're going to plug in 2/3 everywhere we see an x. The nice thing being, we have an x on both sides. So that means that this is going to have a measurement of 2/3 meters. And this will also have a measurement of 2/3 meters. So we can kind of block those off because those are 2 of our 4 sides. Now we need to find this remaining side. Once we find this one, we know that this is going to have the same measurement. So that's the nice part there. So we got to take 2x plus 4 and plug in our 2/3 for the x. Now we would like a fraction times a fraction. So what we want to do here is we want to change this integer to a fraction. Any number, any integer can be written as itself over 1 because it doesn't change in value. Just think of this. This is 2 divided by 1, which is still 2. But now I have a fraction times a fraction, which means I can multiply the numerators together, 2 times 2, to give me 4. I can multiply the denominators together, 1 times 3, to give me 3. Okay? Now, as I transfer this plus 4 down here, since we're still going to be dealing with a fraction, it might be best to go ahead and change this plus 4 into a fraction. In which case, we're going to use the same mentality as we did over here. So instead of being plus 4, we're going to have plus 4 over 1. Now, we need to combine these fractions together. And in order to add or subtract fractions together, they have to have a common denominator. So we want to figure out, we have a 3 and a 1. What's the easiest way for these two numbers to be the same? The easiest way is to multiply this 1 here by 3. That way, we'll end up having 3's on the bottom of our fractions. But we don't just multiply the bottom, we also multiply the top. So we think of this as multiplying by 3 over 3. Okay? When we do that, the first fraction we didn't do anything with, so it's still the 4/3, plus we multiply straight numerators and straight denominators here. 4 times 3 gives us 12. 1 times 3 gives us 3. Now that we have common denominators, we can add the fractions together. When adding or subtracting, we keep the denominator the same and just combine our numerators. 4 plus 12 gives us 16. So I have 16 over 3. All right. Now that does not simplify. We could write it as a decimal of 5.333. But since we're just looking for the side measurement here, we can actually go ahead and be done with this side. So we have 16 over 3 meters. And the nice thing here is, this side was 16 over 3 meters. This top side is also going to be 16 over 3 meters. Now, before moving on to the next problem, what we want to make sure is, did we find the value of x? Yes, we did. Did we find the side measurements? 1, 2, 3, and 4. Yes, we did. All right, moving on to this next one. I didn't give you time. I didn't give a moment to pause here, so if you want to look at that and pause the video and work it on your own, you can. Okay, looking at this one now. Still dealing with perimeter. They tell us the perimeter of a triangle is 63 units. And what might help us here is to go ahead and circle some interesting facts that we know. So we know the 63 units. If we look at the very end, actually, if we skip ahead, we see that we have to find the value of x and the 3 side measurements again. So we know we're basically going to be doing the same steps as before, but the problem is here, we don't have a diagram. They do tell us that we're finding the perimeter of a triangle. So what we could do to help us out a little bit is, let's go ahead and draw a triangle. I will tell you, I've drawn 7 different triangles now, 6 with my first 6 period classes. So it does not matter, just a heads up, on what type of triangle we have. As long as it has 3 sides, we can classify it as a triangle. Now, let's take a look here. They tell us some information about the sides. They tell us that one side measures x. That means that one of these sides is straight up just going to be the variable x. So the first step would be to go ahead and put one of the sides as x. Now, when they talk about the second side and the third side here in a moment, they're referencing the first side. Okay. If you're watching this video right now, just ignore that part. So we're going to continue here. They say the second side measures 4 more than twice the first side, which might be a little confusing. But if we break this down into 4 more and twice the first side, it might be a little bit easier. So let's focus on what it's comparing itself to the first side. It says it's twice the first side. That means it's double, basically, of what this first side is. So if we were to take this side and double it, also known as multiplying it by 2, we would end up with 2x. Now, that's just this first part here. We don't want to forget that it also says 4 more than twice. And how we reference 4 more in these problems is this means they want to add 4 to twice this number. So we want to do the same over here. Now, we can't combine these together once again because we have unlike terms. And we don't know what x is, so we can't really do anything to it. So we have to create these equations, and then we'll be in a similar situation that we were in the previous problem, where we can add all the sides together, set them equal to what they tell us the perimeter is, and solve for our variable. Let's look at the third side here. The third side is 5 less than 5 times the first side. So they're referencing this side again. So they have 5 less, and they have 5 times the first side. So since the first side was x, they want 5 times that x, which means we're going to have a 5x. Then finally, we can reference the 5 less than this number, which means less than is going to be represented by subtraction. So we're going to have a minus 5. Okay? Now, all we need to do is add these 3 sides together, just like we did in the previous problem. We're going to add all 3 sides together and set that equal to what they tell us the perimeter is, which is 63. All right? Next, we want to add all of our x's together. Once again, if you need to put the 1 out in front of the x, do so. Because this should tell us we have 1x, we have 2 more here, and we have 5 more here. So really we have 1 plus 2, which is 3, 3 plus 5, which is 8x. Okay? Next, we want to combine our integers, or our constants. Doesn't have to really be an integer or something. I have a 4, and I want you to be careful. You have a negative 5. So we have a positive 4 and a negative 5. We don't want to just treat it as a 4 and a 5 and get 9 there, okay? So we're going to have 4 minus 5, which is going to give us a negative 1. Then we can continue the rest of our equation here, and we're back to solving linear equations. We want to get rid of minus 1 by adding 1 to both sides. The 1s are going to cancel out on the left, leaving us with an 8x is equal to 63 plus 1, which is 64. Then we want to get rid of times 8 by dividing by 8. The 8's go away on the left side, leaving us with x is equal to 8. This one's nice. It turned out to be an integer, which is going to be a lot easier because, yes, this is part of our answer, but we also want to plug this into everywhere we see an x to get our additional values. Now, what's easy is this one's just x, so really when we plug it in, it's still going to remain 8. Now, side note here for geometry. What's the increments for this? They tell us that the increments are u, which stands for units. Sometimes they won't tell us meters, kilometers, inches, centimeters, whatever it may be. They'll just use a u. And anytime you don't know the increments of a problem, always use u. Okay? There's 8 units. Let's go ahead and plug in 8 into this equation. So we're going to have 2 times 8 plus 4, which gives us 2 times 8, which is 16 plus 4, which ends up giving us 16 plus 4, which is 20 units. Okay? Plug in 8 into this final one here, the 5x minus 8, sorry, 5x minus 5, my bad. So we end up with 5 times 8 minus 5. 5 times 8 is 40. 40 minus 5 ends up giving us 35 units. Okay? And how we can check that real quick is we can add all 3 sides together. So 8 plus 35 is 43. 43 plus 20 is 63. And that was our perimeter in the very beginning. Once again, we know we're done though when I have a variable, when I solve for x, and I found all 3 side measurements. Let's go ahead and take a look at this last one here. I'll give you another second to look at it before I move on. Okay. Geometry here. The sum of any quadrilateral angles is 360 degrees. Okay? Now we are talking about the interior angles here, so I know it doesn't say that up there, but we were talking about the angles on the inside here. They want us to determine the value of x and the angle measurements of the following figure. So once again, they're wanting us to talk about those 2 parts before we're done with the problem. Now, if it's a little bit hard to see, I'll let you know that this right here says 6x, this says 4x, this says 2x, and this says 60. It's okay if they all don't have a variable, okay? What we do know is that all four of these numbers have to add up to be 360. So we should go ahead and write 60, 2x, 4x, 6x. Those are our four angles. We're going to add all four of them together, set that equal to 360 degrees, or just 360, since we're just going to be doing the math. Okay, let's focus on combining all of our variables together, 2x, 4x, and 6x. Okay, 2 plus 4 is going to give us 6. 6 plus 6 is going to give us 12x. Okay. Now, we only have one number on the left side, just that 60, so we're just going to go ahead and bring it down here. So we're going to have 12x plus 60. And once again, we can't combine those together because they're not like terms. And we're still going to have that set equal to 360. And once again, we have another linear equation, so let's solve. Got to get rid of the plus 60 first by subtracting 60 from both sides. 60's go away on the left, leaving us with 12x is equal to 300. Got times 12x. Sorry, we got 12 times x. We want to get rid of times 12 by dividing both sides by 12. 12's are going to go away on the left, leaving us with x is equal to 300 divided by 12 is 25. Now keep in mind, it's not always going to come out to be an integer, but it is nice when it does because it makes this next step a little bit easier. Okay? Because all we need to do now, that's part of our answer, is plug in 25 everywhere we see an x. But we do want to find all four angle measurements, and they actually, once again, a reminder, we only have that 60 right here. So 60 degrees is one of our angles. Okay? Now, if we plug 2x in over here, we plug 25 in for this angle. We're going to have 2 times 25, so that's going to be 50. And so another one of our angles is going to be 50 degrees. Down here we have 4, so we're going to have 4 times 25, which ends up being 100 degrees. And then over here we have 6, so we'll do 6 times 25, which will give us 150 degrees. Now, before we circle these as final answers, one way we can check is all four of these angles, once again, have to add up to be 360. So if I add them real quick, 150 plus 100, 250. 250 plus 50, 300. 300 plus 60 is indeed 360. So those are going to be the four angles for this given problem. Once again, a nice way to always check to make sure we're done. Did I answer all the questions? Did I answer all the things that they were looking for in the question? The value of x is 25, and all the angle measurements. There are four angles. Once again, if you have any questions, feel free to send me an email, and you should be ready to complete the assignment over 1.2.2.